Hello and welcome to the second video on the math that you need to know to successfully compete in the Intermediate Math League of Eastern Massachusetts. Today we'll be continuing on with the geometry section, so let's dive right in. So the first thing that we need to talk about are angle equality rules. There are only two equality rules that you'll ever need to know from Meet 1 geometry. And the first rule is that opposite angles are equal. Opposite angles are defined as angles that are on opposite sides of intersecting lines. So whenever two lines, three lines, however many lines intersect at a point, opposite angles will always be formed. In the diagram to the right, angle A and D are opposite angles because they're on opposite sides of these intersecting lines. And angles B and C are also opposite angles. So using this first rule that opposite angles are equal, we can immediately say that angle A is equal to angle D, and angle B is equal to angle C. The reason this may come in handy if you're doing an IMLEM question is because if you know the value of angle A and angle D is part of a larger figure, you can immediately say that angle D will be equal to whatever angle A is, and then use that measure in the larger figure to help you get your answer. And then the second rule that you need to know is that corresponding angles on parallel lines are equal. So corresponding angles are defined as angles on the same side of a set of lines in an intersecting line. So there can be corresponding angles corresponding angles form on three lines. Two lines that are almost parallel or can be parallel to each other, and then a third intersecting line. But the corresponding angles will only be equal if the two lines are parallel to each other. And so that might be a little bit confusing. So to make it a little bit easier to understand, there's a diagram to the right that's about to pop up. So in this diagram, there's a set of parallel lines. And the way that we know that these lines are parallel is because they have arrows on the lines pointing in the same direction, which means that they're parallel. And those are these arrows right here. So whenever you see those on lines, that means that those lines are parallel. And I'll just highlight them for you so you can see more easily. So the corresponding angles on these lines are these angles and then these angles. So the reason that these are corresponding angles is if we apply our definition, they're angles on the same side of a set of lines. So in this case, our set of lines is the parallel lines. So in this case, they might be on the left side and an intersecting line. So they might be on the top side. So both of these angles are on the left side of this line here, the set of lines, and they're both on the top side of this intersecting line, which is what makes them corresponding. And since these lines are parallel, we can apply our corresponding angles, our parallel rule, to say that this angle will be equal to this angle over here. And same with this. This angle is also equal to this angle over here. Now we're going to be talking a little bit more about polygons. So the definition of a polygon is a closed shape with three or more straight sides and angles. So polygons can't have any curved sides, and they have to have angles. So a circle wouldn't be an example of a polygon because a circle only has one side, and that side is curved. But something like a rectangle, a square, a triangle, those would all be polygons because they're closed shapes, which means all the lines touch each other, with three or more straight sides and angles. So there are a few types of specific polygons that you will need to know by name that might show up in IMLEM questions. And those are listed below. So triangles have 3 sides, quadrilaterals have 4 sides, pentagons have 5, hexagons with 6. For 7 sides, we can call it either a septagon or a heptagon. It really doesn't matter. An octagon is 8, and so on. So these are the types of polygons that you'll need to know by name rather than by the number of sides. And what that means is if you have a question and it's referring to a polygon with 18 sides, it will call it an 18-gon. But if it's referring to a polygon with 12 sides, they might not call it a 12-gon, they might call it a dodecagon. And you'll have to know what that means in order to solve the question. So probably the most common polygon that you'll see in IMLEM questions is the triangle. And triangles are super important in IMLEM, and in geometry specifically, because they make up a lot of larger shapes. So there are a few specific rules that you might need to know about triangles that will help you solve the rest of the question. So this rule is probably the single most important rule that you need to know for Meet 1 geometry. and that's the triangle sum rule. So in a triangle, all three interior angles will add up to 180 degrees. So it doesn't matter what type of triangle it is. It can be a right triangle, an obtuse triangle, equilateral. It doesn't matter. In any triangle, all three angles will add up to 180 degrees. So knowing this allows you to find the measure of a third angle if you know two of the other angles, because you know that whatever the third angle is, it's whatever you need to get to 180 from the sum of the other two. And then the next thing you need to know is something called the n-gon formula. So we already know that the three angles in a triangle all add up to 180 degrees. But what about in other shapes, like a hexagon or a pentagon or a dodecagon? So this formula allows you to find the sum of all the angles in any shape. And that's what we call the n-gon formula. So the n-gon formula is n minus 2 times 180 will give you the sum of all the angles in the shape. So n is what we call a variable. It represents some number. So in this case, what n is representing is the number of angles or sides in a shape. So for instance, if we wanted to use this formula to find how many degrees there are in a four-sided shape, we would need to figure out first that n would have to be equal to 4. Because in this case, with a four-sided shape, it has 4 angles and 4 sides. And that's what n represents, the number of angles or sides, which in this case is 4. So the way that we go about solving this is we put in 4 in the equation where n would be. So we start with our equation n minus 2 times 180, and that becomes 4 minus 2 times 180. And then you simplify the equation until you get your answer. So 4 minus 2 is 2, and then you still have to multiply by 180, and then that gives you 360 degrees total in a four-sided shape. And the reason that you have to do 4 minus 2 first, or whatever n minus 2 is because it's in a parentheses. Anything in a parentheses you always have to do before you do anything else. And so it's also important to know why this formula works, because a lot of the time you're going to encounter formulas, but you might not understand why it works. I can tell you n minus 2 times 180 is the sum of all the angles in the shape, but that might not make sense to you. So to explain why that might make sense, we have to look back at triangles. So to the right, I have 3 diagrams, one of a quadrilateral, one of a pentagon, and one of a hexagon. So in the quadrilateral, it's divided with a diagonal that cuts it into 2 triangles. In the pentagon, it's cut into 3 triangles. And in the hexagon, it's cut into 4 triangles. In each triangle, there's 180 degrees total. Because of our triangle sum rule, we know that all the degrees in a triangle is 180 degrees. So if there are 2 triangles in a square, or in a four-sided shape, that means there are 360 degrees total, because 180 degrees per triangle. In a 5-sided shape, we can make 3 triangles. And that means that there has to be 540 degrees total, because 180 per triangle times 3 is 540. And so on in a 6-sided shape, when we can make 4 triangles, there's 720 degrees total, because 180 degrees per triangle times 4 total triangles in the shape will be equal to 720 degrees. And that's where our formula comes from, because the n minus 2 section of the formula that's in parentheses is how you determine how many triangles make up a shape. In a 4-sided shape like we have, there are 2 triangles that make it up, which is why we do 4 minus 2 equals 2. In a 5-sided shape, there are 3 triangles that make it up, and that's 5 minus 2 equals 3. And in a 6-sided shape, there are 4 triangles that make it up, and 6 minus 2 is 4. And this will work for any shape. If we had an 1,000-sided shape, I could definitively say that we can make it up with 998 triangles, because I know that n minus 2 is 998, and that's the rule that works with any polygon. And then the next part of the formula, times 180, is just multiplying the amount of triangles that you have by the total number of degrees per triangle to find the total number of degrees in total, or in the entire shape. So that's how the n-gon formula works. It uses how many triangles there are to find the total number of degrees in a shape. But the triangle sum rule is definitely something that you should remember, because that's what this entire formula is based on. And in many IMLEM questions, you'll see triangles that you have 2 measures of angles, and you can easily find the third. Okay, so next we're going to do a review question, or two review questions actually, based off what we already learned in the previous sections. So if you want to attempt these review questions, I'll give you a few seconds to pause the video before I explain how to do it. So the answers to the questions were, for the first question, 1,800 degrees, and for the second question, 54 degrees. So let's go over the first question. So it asks you to find the sum of all the interior angles in a dodecagon. So when you see this question and you see sum of all the interior angles, you should recognize that you have to use the n-gon formula for that, because that's the formula that allows you to find the sum of all the angles in any shape. So we have to use the n-gon formula to find the sum of all the angles in a dodecagon. So if you remember back to when I was going over the different types of polygons, you'll remember that a dodecagon is one with 12 sides, which means that we can use that in the n-gon formula to find the total number of degrees in that shape. And the way we do that is first we need to write out a formula. That's super important. Always write out your formula first. In this case, our formula is n minus 2 times 180 will be equal to the sum of all the angles. Sum of angles. So in this case, we know that the shape has 12 sides and 12 angles because it's a dodecagon. So in place of n, we substitute in how many sides or angles it has. So that's 12. And then we write the rest of the formula just like it was. So the next thing that we need to do is whatever's in the parentheses, which is 12 minus 2. So that will be equal to 10. And then you always have to remember to write the rest of your formula. And then finally, we have 10 times 180, which is just adding a 0 to 180. And that gets you 1,800 degrees. And that's how you get your answer. So for the second question, it says if BAC is 80 degrees and ACB is 46 degrees, find the measure of angle ABC. And so the answer to this question was 54 degrees. So the reason that this was the answer is because if we have the triangle sum rule, we know that all the angles in a triangle add up to 180 degrees, and we have two of the angles, we can find the third angle. So when you're reading questions like this, if it specifically tells you angle measures, the first thing that you should do, and I said this in my previous video, is label those degree measures on the actual figure. And if there's no figure, you should draw one. So it says if BAC is 80 degrees, so you want to stop and label BAC as 80 degrees, and ACB is 46 degrees. So again, you want to stop and label ACB as 46 degrees. Then find the measure of angle ABC. So the way that we do this is we know two of these angles, and we need to find this third angle, which you should always label with a question mark to know which angle you're trying to find. And we know that they all add up to 180. So using a bit of simple math, we can figure out what 46 plus 80 is. So that's going to be equal to 126. And then we know that the last angle, angle ABC that we're trying to find, must add with 126 to get 180. And so all you have to do is subtract 126 from 180 to get your answer, whatever's left. In this case, that's 54 degrees. So there's also one more specific use for the n-gon formula, and that's that you can change the n-gon formula up a bit in regular polygons to find the measure of one interior angle. So what that means is the definition of a regular polygon is any polygon which has all sides of equal length and all angles of equal measure. So for instance, a regular quadrilateral would be a square, because a square has 4 90-degree angles and 4 sides of equal length. And so in a regular polygon, you can use the n-gon formula to find the measure of one specific angle, because you know that all the angles are the same. So finding one angle should be a little bit easier than in different shapes, because you can just divide by the total number of angles. So what that means is you need to adapt the n-gon formula to find the total number of degrees per one angle in a regular polygon. And the way that you do that is first you need to use the n-gon formula to find the total measure of all the angles. And then you want to divide by the total number of angles to find the measure of one angle in that shape. And so written out in a formula, it looks like this, where you have n minus 2 times 180 in the top part of the fraction, which is what we call the numerator, and that's the total number of degrees in the shape. And then in the bottom part of the fraction, which is what we call a denominator, or what we're dividing by, we have n, which is the total number of angles. And again, we have n in this formula because n is the total number of angles that we have, and above n is the total number of sides or angles that we have to find the total number of triangles in the shape. So the reason that this works is you have the total number of degrees, and you're dividing by the number of angles. So it becomes total number of degrees per angle. So I have a review question here, and that's that find the measure of one interior angle in a regular hexagon. So if you want to try this review question, you should pause the video now. I'll give you a few seconds, and then I'll go over it. So the correct answer to this question was 120 degrees. So the way that we find this is we need to use our formula in regular polygons to find the measure of one interior angle. And that's our adapted n-gon formula. Because we know that to find the measure of one interior angle, you need to find the total number of degrees in the shape first, and then divide by the total number of angles. So to do that, we can write out our formula. So our formula in this case is n minus 2 times 180 to find the total number of degrees in the shape. And you want to put that in a parentheses because you need to do that first. And then you want to divide that by n, the total number of angles, to find the total number of degrees per angle for each interior angle. So what you want to do is you need to recognize that a hexagon is a side with 6 shapes. It won't call it a sixagon in the question. It'll call it a hexagon, and you need to be able to recognize how many sides that has. Otherwise, you won't be able to solve the question. So in place of n, we need to substitute in 6, and then write out the rest of our formula. So right now we have 6 minus 2 times 180 divided by 6 will give us the measure of one interior angle in a regular hexagon. So in order to simplify this, we need to do whatever's in the smallest parentheses first, and that's 6 minus 2. So 6 minus 2 is 4, and then we want to write out the rest of the equation, times 180 divided by 6. Next, you want to do 4 times 180 because that's also in a parentheses before you divide by 6. So 4 times 180 will give you 720. And then you just have to divide by 6 left. Because now you have the total number of degrees in the shape, and you're dividing by the total number of angles to find the total number of degrees per angle, because all of the angles have the same measure. And then if you divide 720 by 6, you get 120 degrees for the measure of an interior angle. The last thing that we're going to talk about in today's lesson is exterior angles. So we already talked about interior angles, which are the angles on the inside of a polygon. An exterior angle, just as it sounds, is the angle on the outside of a polygon. But it's a teensy bit more complicated than that. So the definition of an exterior angle is the angle between a side of a polygon and an extended adjacent side. So what that means is if we have the side of a polygon, so for instance, we have one exterior angle labeled on this diagram here, but I'll show you another. So if we take a side of the polygon like this one, and we extend that side, that's what we call the extended adjacent side, then we can use our definition to figure out that an angle between a side of a polygon, in this case if we're looking at this side, and an extended adjacent side, which is this one, will be your exterior angle. So in this case, this is also an exterior angle of this polygon. So this one's an exterior angle because we extended this side right here, and this one's an exterior angle because we extended this side right here. So with exterior angles, the sum of a pair of interior and exterior angles will always equal 180 degrees. So when I say a pair of interior and exterior angles, that means an interior and exterior angle that's right next to each other. So in the diagram, an interior angle, say, is this one. To make a pair of the interior and exterior angle, it has to be paired with this exterior angle right here, because that's the one that's right next to it. And so we know with this rule that those two angles will add up to 180 degrees. And that makes sense, because if we extend a straight line here, we know that this straight line is 180 degrees. It's half of a full rotation, which is 360. And so if this is half of a full rotation, a straight line, 180 degrees, then the two angles on it, which are the interior and exterior angle, have to add up to 180. So another really useful rule about exterior angles is the exterior angle formula. So all the exterior angles in a shape will always add up to 360 degrees. So no matter how many sides a shape has, the exterior angles will always add up to 360 total. And so with this, we can create a formula to find the total number of degrees per exterior angle in a regular polygon. So the reason that this doesn't work in non-regular polygons is because the exterior angles will be different. But in a regular polygon, say we had a regular equilateral triangle like this, all of the angles are the same. And so are all the exterior angles. If I extend all of these sides, it's pretty easy to see that all of these exterior angles actually have the same measure. And that means that you can use this formula that you know that all three of these angles add up to 360 degrees to find the total number of degrees per exterior angle. So in this case, if we had an equilateral triangle, then n would have to be 3 because there are 3 sides, 3 angles. And so 360 divided by n, in this case, would get you 120 degrees per exterior angle in a regular triangle. And so it's important to remember that this only works for regular shapes. So the rule that they all add up to 360 works for any type of polygon. But for regular shapes, you can use a formula to find the total number of degrees per each exterior angle, just like we did with our interior angle n-gon formula. And then the final thing that we're going to do in today's lesson is to do a review question about exterior angles. So this is actually our first review question from an actual IMLEM meet from October in 2000. So if you want to attempt the question, again, I'll give you a few seconds to pause the video and then I'll go over how to do it. So the correct answer to this question was 20 degrees. So we know that this shape that they're giving us is a regular 18-gon. So like I told you, in a lot of shapes, they'll tell you how many sides it has in the name of the shape. So in this case, since it's called an 18-gon, we know that it has 18 sides. And we also know that it's a regular polygon because it tells us it's regular in the question. So the question asks us how many degrees are in an exterior angle of a regular 18-gon. Well, in order to solve this, we need to use our exterior angle formula, which tells us that all the angles add up to 360 degrees. And in a regular polygon, if we divide by the total number of angles, or in this case, I guess exterior angles, we can find the total number of degrees per one exterior angle. So in this case, if we write a formula, 360 over n equals degrees per exterior angle, and then we substitute in 18 for n because that's the number of angles that we have. We can do a little bit of simple division, 360 divided by 18, to figure out that one exterior angle in an 18-sided shape is equal to 20 degrees. So that's all I have for you today. We talked a lot about equality rules, we talked about opposite and corresponding angles, and we talked a lot about the n-gon formula, which is a new formula we learned, along with interior angles and exterior angles and regular polygons. But I'll just do a quick review of what we learned, just to make sure that you got it. So first we talked about equality rules, and we learned that opposite angles are equal, which are angles that are on opposite sides of intersecting lines. It doesn't matter how many lines there are. And then we also learned that corresponding angles on parallel lines are equal. We went over the definition of a corresponding angle, which is an angle that's on the same side of a set of lines in an intersecting line. And so we learned that when these two lines are parallel, the set of lines are parallel, that the corresponding angles are equal. It doesn't work if they're not parallel though. Then we talked about types of polygons. We went over the definition of a polygon, which is a closed shape with 3 or more straight sides and angles. And then I told you about a few polygons you might need to know specifically by name that might show up in a question. After that, we talked about triangles and the n-gon formula. So the first rule, the triangle sum rule, is super important, that all the angles in a triangle add up to 180 degrees. And then the next thing is the n-gon formula, which is to find the total number of degrees in any shape. And we went over the reason that this works because the n-gon formula figures out how many triangles there are in any type of shape and then multiplies that by 180 degrees to find the total number of degrees per all the triangles or per the entire shape. Then we did 2 review questions, first finding the sum of all the interior angles in a shape, and then using the triangle sum rule to find the measure of one angle in a triangle. After that, we went over using the n-gon formula in a regular polygon to find the measure of one interior angle. And we define a regular polygon as any polygon with all sides of equal length and all angles of equal measure. And so we figured out that if we take the total number of degrees and divide by the total number of angles, which is n, we get the total number of degrees per angle. And then we also did a review question with that, where we find the measure of one interior angle in a regular hexagon, which was 120 degrees. And then finally, after that, we talked about exterior angles, which is the angle between the side of a polygon and an extended adjacent side. We figured out that a pair of interior and exterior angles always adds up to 180 degrees because it's on a straight line. And then we created a formula from the fact that all the exterior angles in any shape will add up to 360 degrees. So we created this formula to figure out the measure of one exterior angle in a regular polygon, which is where all the exterior angles would be the same. And then the final thing that we did is we went over a review question, our first review question from an actual competition, to find the total number of degrees in an exterior angle of a regular 18-gon. And we figured out that was 20 degrees. So that's all I have for you today. Today we talked a lot about polygons and triangles and equality rules with angles. Next time we're just going to talk a little bit more about triangles, and then we're going to dive a little bit into some algebra-based geometry questions, which are questions that you'll encounter that you'll need to know algebra to solve. So we're going to dive into that next time, but I hope this lesson was helpful and you could understand a little bit more about degrees in certain polygons, and I hope you can apply this into your IMLEM questions.